My name is Niran. I am like 20 years already, over 20 years VMware practitioner, working for VMware for 9 years. And recently, like a year ago, I've transitioned into a product management role. And now I'm a product manager for the product called Tanzu Service Mesh that I'll show you today. And that's me. How about we would love to hear from you guys, like what do you do? Where do you work, and why did you come to listen to this presentation?
I can go. My name is Wade Mayer. Right now I'm working for Five Below, if you know the stores, retail stores, systems engineering team. So focus a lot on storage, and some of our workloads are in the cloud. And so, I mean, today I wanted to learn from more seasoned folks, just kind of what to expect moving forward, and just to keep sharp. Like Ben usually always puts together a good lineup, so always learn a lot.
Thanks, Wade. I have Rose next on the list.
Hi, I'm Rose. Right now, I'm just doing contract work for some HPUX, but I'm also doing. I used to do some VMware, and I just want to keep on steady with some of the VMware information.
Okay, thanks, Rose.
You're welcome.
Ralph.
So my name is Ralph Migliore. I work with Ben to more so when we had the in-person events, to manage the event and everything. But I help out as much as I can. I work for an insurance company in New Jersey, and I have somewhat of a knowledge of the different topics related to VMware, but I want to get more knowledge in what we're about to talk about today, so that when people are talking, I know what they're talking about.
All right, thanks, Ralph. Did we lose someone else? Yeah. All right, let me show you. I want to do it differently a bit. I want to start from the demo, and then I'll explain what it is that we see, because I think it is more impactful if we're doing this with the demo. We just explain what it is that I'm going to do here. Hold on. So I got an app that has a front-end service called shopping and a back-end services, different services that comprise of the application. This is a microservices application. That means that the different functionalities of the app are written in different containers, right? Different kind of hosts on the network. And they need to kind of find and communicate with one another, where I deployed the front-end components in Azure, in AKS, US East and US West. And I've deployed the backend services in AWS, in US East and US West AWS. So I'm going to create the full mesh of my application connectivity across different clouds and across different zones. I'm going to assign a domain name for what's called service discovery. This will allow the application services to find one another, not based on IPs, but based on a domain name. So basically, shopping will call out catalog by calling it by catalog.acme.lab, and the system will automatically plumb down the DNS record so the services can find one another. And all the communication is going to be encrypted with MTLS, which is mutual TLS, right? It's basically mutual authentication between the services. And lastly, I'm going to publish the application out through a global load balancer. So there's going to be an AVI Networks global load balancer, which is VMware's load balancing solution, that will automatically be set up to point to the two Azure sites. Actually, this GSLB runs in AWS, but doesn't matter. It will point to the two AKS sites. Azure Kubernetes service will send traffic down to the shopping service here that will communicate back to the backend services like catalog. Now, all of this multi-cloud, multi-cluster connectivity of an application with full encryption and publishing through a global load balancing solution will happen in 3 commands. They're basically going to apply a manifest, and I'll explain afterwards what exactly it's doing in the back end. But it's going to apply like a YAML file that's going to create this connectivity and automatically make the application work. Does that make sense? Now, this will create something called a global namespace. That's Tanzu Service Mesh basically creates some like a container, it's more of a folder, logical folder that has mapping to the different services that needs to communicate with one another. This global namespace is a logical construct that lives in our SaaS service. And it basically has link connectivity, or basically it sends down configuration to wherever those services are to make sure that they can talk. And encryption is set up, certificate set up, everything set up automatically, right? I don't need to set up any special VPNs to connect these things. I don't need to do anything. All the encryption is happening from service to service based on the fact that we're going to apply proxies in. I'm going to explain the technology after the demo. Now, this demo is going to be 2 parts because I'm going to create this connectivity, then I'm going to explain the technology. Then as time permits, I'll show you also the policies we can apply on this global namespace. We can basically apply security policies and PII data security policies and threat detection and all kinds of things on this folder we call the global namespace, which is our application that works across clouds. Are we good on the demo? Like what's gonna happen?
I think so.
Okay, let's see it first, and then. So I got here Tanzu Service Mesh, and Tanzu Service Mesh. Why is it stuck? Okay, Tanzu Service Mesh is a SaaS service. As you can see here, I'm attached to the service, and I'm basically connecting to the SaaS service Kubernetes clusters, which are kind of I don't know if you guys know or don't know what Kubernetes is. It's basically an orchestration solution that has also infrastructure management and everything in it that's pretty popular today to run cloud native applications. So I got these 4 Kubernetes clusters that I mentioned, the 2 Azure AKS clusters, which is all Azure, and the 2 AWS clusters with the services deployed on them. You can see the services already deployed on them because there's some communication going on within the back cluster, but really they're not communicating with one another currently. And I'll show you that. But basically, those are the 4 clusters we saw here, right? The 2 Azure ones and so on. You can see the services, the shopping service here, right? Now, what I'm going to do, first I want to show you how it looks before I create the connectivity. So if I go to my Azure cluster, one of them, let's say the Azure East one, and I do kget pod, you'll see that I have the shopping service here, right? If you look here, sorry. If you look here, that's the front end service here, right? It's running on the AKS cluster. I'm going to connect to the cluster directly without the global namespace and the global load balancers and all that. I just connect to the cluster directly so we can see how it looks, right? So I'm going to do kget service, and I'm going to do Istio system. It's basically where you can see the IP that I can connect to the cluster, and I'm going to put it here. And you see that I'm connected to the front end application. It tells you that this front end is running on Azure US East, which is exactly what we expected, right? In Azure US East. And if I click on catalog, you'll see that it's empty. And again, that's because this connectivity here is not set up yet. Okay? Now, if I look at the deployment for shopping, you'll see that the application is set with some environment variables. That it's built in a way that allows us to inject the DNS FQDN of my services. So in a matter of fact, when in the code of the application it says when shopping needs to talk with catalog, it basically goes to environment variables called catalog host that will look for how the catalog host is supposed to be called. In this case, I called it acme.lab. That's basically the global namespace domain that I created for connectivity, internal connectivity between the services. So let's go and create this connectivity, right? Oh, and lastly, sorry, I got a global load balancer here with GSLB that's empty. I want to show you it's going to create that as well. So I got 3 YAML files here. I got 4, but I'm going to do 3. The global namespace YAML, and then the public service and the public route that will allow me to publish the application outside through the global load balancer. If I look at the global namespace YAML file, you'll see that it's very simple. It just says, this is, remember, this is the acme.lab. Now, the idea is if I'm a developer and I'm deploying this to a global namespace production, I'm going to call it production.something, and we'll deploy it to a dev, I'm going to call it dev acme.dev.something, so that I can inject that into the environment variables, and the connectivity map will change based on the global namespace I'm deploying to. So in this case, I'm saying this is the domain name, this is the name of the global namespace, and these are the clusters that you're supposed to, and the namespaces within them that you're supposed to pull the services from. So that's how it knows what to talk with, what talks with what. So I'm going to go and apply that now. I'm going to do Tanzu Service Mesh apply the global namespace. Tanzu Service Mesh apply the public service. And Tanzu Services apply the public route. That's all I need to do. Now, if I look here and I click this empty GNS, you see that it got created. I just created it with this command. If I look inside, refresh this, so make sure that's up to date. If I look inside, you see that it gave it the name that I told it, the domain name that I used, and the clusters are pulled in based on the criteria that I set up in my YAML file. And lastly, I published the shopping service out through the global load balancer with this FQDN. And if I go here, you see that it created my FQDN on the global load balancer. So now my application should be working. And now you see that I'm connected to Azure East, but I get pictures from AWS. Now, what I'm going to do is I'm going to quickly give you guys so you can create some traffic for me. So if you can go into the application and click through some pages, because what will happen if you look in my screen is that I'm going to start seeing the traffic that you guys are creating. Still not seeing any traffic. We'll see the traffic soon. No cross-cluster traffic yet. There you go. Oh my God. All right, there's a lot of lines here, but what it did basically, once you start clicking through pages, it sees the traffic and basically builds a map of the connectivity. So now I have connectivity. You guys are coming into the Azure sites and then to the AWS sites in the backend. Basically, full multi-cloud application with the encryption and published through a global load balancer out to the world. And I did that in a few steps. That's the basic demo of the global namespace before I get to like policies and stuff and explain to you what actually we saw here. But did it make sense kind of what we did?
It did. Thanks, Niran. Can I ask something real quick here? So, you know, I don't work directly out of Tanzu or anything yet, but so you started the service. This is what's connecting them. But if you're not using the Tanzu mesh, after you establish these paths and routes, is it actually relaying through Tanzu to control these connections since you're reaching out, or like if for some reason access to Tanzu disappeared?
Let me first explain something. Tanzu is a suite of products. This is what I showed you is Tanzu Service Mesh. Okay. It's actually connecting the services running on non-VMware technologies. This is Azure Kubernetes service. There's no VMware in here. And this is Amazon. There's actually TKG clusters on Amazon. So the Kubernetes is VMware, but this is all Amazon. It really doesn't matter what this runs on. As long as Tanzu Service Mesh is creating the connectivity between the services, okay? Now, the traffic is only point-to-point from service to service. It does not need to flow through any SaaS service. Our SaaS service only creates the management and control of the configuration down. The traffic actually flows from the catalog directly to shopping, full MTLS with no decryption or termination in the middle. It's basically, and I explain the technology now, it's basically proxies that are attached to each one of those services. And those proxies talk with one another. And that's the way it works. So they establish a mutual TLS between them. That make sense?
Yes, thank you for that clarification.
Right, let me explain what we saw here, because I know it seems like a magic overwhelming a bit. Let's go backwards. So the idea behind microservices, I'm sure most of you know, is basically taking the what we call the monolithic apps, where all the code is jumbled in the same code base and all the communication is over RPC, right? It's all running the same computer. Where we broke it off to microservices. Basically, each function now is a host on the network. It's basically containers running in different places talking to one another. So this may be the front end, this may be the catalog, this may be the search engine, this may be the authentication service. And we have different teams kind of innovating on them. The idea is the developers now, if I'm making a change to the catalog, I can push to production without regards to all the rest. All the stuff here is communicating over the network over APIs. So it's all TCP IP connections, but still this talks with APIs with these and so on, right? Now, it changes things a bit. It allows our developers to be more innovative, right? I can push code faster. I don't need, if you guys remember, like semi-annual disruptive upgrades, this doesn't require that. I can push code every 2 weeks, every sprint, make changes, I add features, I can push them in to each one of those functions and they will work independently from one another. The problem is, and the challenge is that now everything is over the network. So if I didn't have to set up, the logic of how stuff communicate, where DNSs are, certificates for encryption and all of that, in the past, I didn't need to do that because all running the same computer. Now, developers need to work on what's called non-business logic, a lot of non-functional work, stuff to make this operate. So imagine now the amount of work developers need to spend in making this very distributed, very complicated application working is complicated. It's a lot of work. So Service Mesh basically abstracts all this stuff out. And what VMware did is we took this abstraction, just like we did on vSphere, and we built on top of it. Let me explain. So we have this application, right? Now, if this service is a web service, then a developer basically needs to write this web service logic. I need to fetch data in some way and put it on a web page. That's what I'm a developer supposed to spend my time on. But if it's on the network, this service needs to find the services it depends on, and services that depends on it needs to find it. I need to tell it how to do that. Should I write IPs in the code? Should I write a DNS? What's DNS? If I'm a developer, should I do all of that work? What about certificates? If this is over the network, I want to now encrypt the traffic. That means I need to have certificates everywhere. Who manages the certificates? Who writes the logic of how the application uses the certificates? And it used to be controlled in the past with something called libraries, which are very language specific. It's not really the right solution. The things, problems with latency. This is over the network. If I introduce latency here, then this entire application will suffer, right? Because it's slowed down. This is now over the network. I got the innovation side, but I need to take care of all these things, like what happens if the service fails? Do I need to write this logic in the application? What you see in here is my service now. It has the web service, which is what we refer to as business logic, functional work, you know, what the business needs. We got all this extra stuff to do, which I call plumbing or non-functional work that is required to make this work in the microservices world. That means now that first and foremost, developers are spending their time on wrong things. This is now increased significantly the amount of time I spend on non-functional work. But more so, remember we talked about getting to microservices for the fact that I can push to production faster and get stuff innovating faster. Now what I need every time I change the configuration, I need to redeploy the service or vice versa, and to disentangle to one another. It basically breaks the whole model. So with service mesh, in general, all service meshes, not only TSM, we abstract that. We attach a proxy. So if you guys know Kubernetes, there's something called a pod. And a pod is basically a set of containers clumped together and as a pod. That's what you deploy in Kubernetes, pods. And usually there's an application service, and that's what's called a sidecar, which is a container that is servicing that application. And in this case, the sidecar is the proxy. Now, what is a proxy? Usually, you know, proxies like when you connect to fetch data for you, or load balancers are proxies. Basically, when you connect to a load balancer, it's connected to services behind it. This is what we call a reverse proxy. It means that it's actually attached to the workload and fronting the workload to the world. And what we do, these proxies talk with other proxies. That's the service mesh. You got a proxy or a load balancer attached to each service and manages all the communication stuff for this service. Now, this code does not need to have all this stuff in it. All this stuff is now on the proxy, and the proxy talks with another proxies. They exchange the data between them. So the way it works actually is there's IP tables here. If I'm trying to communicate out to the catalog from the web service, then all the traffic would be sent through the proxy. This proxy will take the traffic and will send it wherever it needs to go. Now, this proxy will abstract out and take care of all the stuff like DNS, like security, like latency, like communication. All this stuff is going to be managed by that. And when you add a control plane on top to send configuration to the proxies, usually it's a declarative Kubernetes style where you create a YAML file, you send to the control plane. You don't really need a developer to create a very complicated networking construct with security. You don't need to be a developer. You can write the simple YAML file like I did. Every person can do it, apply it, and now developers don't need to manage that. So what are we seeing here? We're seeing creating a mesh of proxies attached to all the services with its own control plane that I can configure in a very declarative, very simple way. I save a lot of developer time spending on nonsense. That's super expensive. Think of any organization that has developers, their top expensive work that you need to spend on other things. There's always missing enough developers to work on actual logic rather than on plumbing. But also, I'm speeding up, innovation. I can now push code to production without regards to configuration, and I can manage configuration separately using pipelines and stuff. And third, it makes the whole thing very declarative, very Kubernetes style, the right way to go, right? Does that make sense of what the service mesh is? If you think about my demo, each one of those services, let me show you actually, why am I just talking? Let me show you on my demo. If you look here, on my cluster, right, I have on my pods, you can see that it has this, the shopping service has two containers in it. If I do k describe pod shopping, you see that inside, if I describe the pod, I go all the way up here, you'll see that there are two containers. Where do I find it? This is one container. This is one container, which is actually, this is the proxy. And there's another container, which is the application image shopping. So there's two containers inside. One of them is a sidecar that does all the communication for me, which is the proxy. Does that make sense?
Yes, that helps.
Hey, Sean. Okay. We're like 3 people, so I allow myself to put people on the spot. All right, so let's look a bit deeper at what Service Mesh can provide, and perhaps I'll show you then like what TSM can do also, and we'll finish there because that's a lot of info. But so I showed you kind of the basic stuff, like what is Service Mesh. Let's talk about the basic features that all Service Mesh has. So I have these 2 services, right? Then I put in a proxy on them, and the first thing Service Mesh will do is set up connectivity, right? So MTLS, discovery. So discovery is just service discovery is just a fancy name for DNS. The idea that I'm automating the DNS entries so this guy can find this guy without needing to use IPs, because IPs always change now. It's really IPs are irrelevant. So it's all layer 7. So if this guy is finding this guy by layer 7 naming, I need to set up automated DNS. Nobody needs to go and write DNS. That's what we call service discovery. So the proxies and the control plane will make sure that all the DNS records are plumbed down to where the proxies can use them on the Kubernetes cluster. There's also traffic control. This is pretty cool because I can now think about this. This is a load balancer. I can control where traffic goes. So let's say this blue one has version 1, now I'm deploying version 2. I made a change. I don't want to in-place upgrade. I'm deploying version 2 next to it. And I can go and set a YAML that says, send 10% of your traffic to version 2. That's called a canary upgrade or progressive upgrade, where I'm sending 10% of the user here. It's really simple. It's a simple YAML that I say send 10% to version 2. It does it. I don't need to be a developer or super expert. I just send 10%. Now I can monitor through the proxies, and we'll see there's extensive observability capabilities from this proxy. I can monitor for errors, like do I get 500 errors and stuff like that. If I get errors, something is screwed up with this upgrade, I'm going to roll it back. I'm going to tell it, send back all the users here. But if there's no errors and doesn't create latency issues, I can change it to 50% and then 75%. And then I moved 100% to version 2. Boom. I've upgraded seamlessly with no downtime, right? So I can do that pretty simply now just by controlling the traffic these proxies produce. It's pretty amazing. We can do also other things like from traffic management. This proxies can understand layer 7. So in a web page, you can have something called an HTTP header. I can put in HTTP header a lot of information. I can put it like who's the user, where is it coming from, or her, which device they're using, which country they're coming from, and so on, right? I can put that in the header. I can identify that when they go into a web page. Now I can set up this proxy to say, it's coming from an Android, send to this service. If it's coming from Apple, send it to this service. Or if it's coming from Europe, send it to this service. If it's coming, I can control traffic based on user headers, on HTTP headers, on these proxies really simply. Simple YAML file, boom, send it to the control plane. In Tanzu Service Mesh, you can even do that from the GUI. You don't have to use the YAML file if you don't want to. There's observability capabilities. I want to give you an example. Think vSphere, if you know vSphere, VMware, right? Virtualization. That's an abstraction layer, very similar to this. It's an abstraction layer between the compute and the operating system, right? Basically, the operating system talks with the virtualization layer, which abstracts out the compute and doesn't need to know the hardware. Now, these abstractions also allows us to do better monitoring. We can use E6 stop and we can use VROPs and all these tools to look in the abstraction layer and see like IOs and memory usage and CPU usage in a way that you couldn't do before. Similar here, we can see latencies and error rates and transaction per seconds. These are layer 7 application information that is important to understand the health of an application. We can use that to see if we need to upgrade, something screwed up, and so on and so on. I can tell you more. VMware has very extensive capabilities on these proxies. We can set up like seeing all the API calls and controlling the API calls. Like if this service does a get from here and suddenly someone hijacked it and tries to do a put, we'll see it and we can stop it, like because we control these proxies. And the interesting part is all of this is encrypted, full encryption. We manage the certificates on these things. So this is where I get to security. What we can see, we can also control. So VMware put filters in these proxies that can see the API calls, can see social security numbers, or any PII data. I can't see the actual numbers, but I can see that there's a certain regex pattern that's passing that tells me that there's PII data that I need to protect. So imagine now this service is the payment service. So credit cards may go here, and I can see that credit cards are going here, but that's okay. But someone hijacked my application, went here and tries to pull the credit cards from here. I can see that and stop it. VMware actually developed these capabilities into this mesh. This service mesh is basically the mesh of proxies that all traffic flows through. Does that start to make sense?
Yes, it's pretty cool. I mean, are you able to show real quick? I know you said, for example, I mean, similar to this with the credit card, but like the Apple and Android example, like switching. I don't know if you have that in place for the demo.
Yeah, it's a traffic steering. It's called traffic.
Right, the traffic control.
Yeah, we can do that. We can do other things. There's a lot, like something called circuit breaking. Just like in electricity, let's say there's an let's say this is the chain of my application. Let's say this is the microservices application. Forget about the versions, whatever. This is front end, back end, even back end more. Now, imagine that there's a lot of traffic coming in here in a way that's overload this service and causing a lot of errors to start. You want to circuit break it. You want to stop from creating congestion on the entire application. We can do that. We can set up something called circuit breaking policy that tells this proxy to circuit break if there's too much load. There's different things you can do from traffic management, but the easiest way to understand service mesh is it's a mesh of load balancers that are reversed. It's a mesh of reverse proxies. We control them easily. We can do a lot of cool stuff on them from a security and observability and traffic control connectivity, and they live everywhere. That's what the service mesh is. It's pretty simple to understand. Cool. So we don't have a lot of time left. What I want to do actually is use this time to show you a couple more things in the demo. Let's leave the slideware for now, because I can spend days on this. Look at my cool application now. I have a traffic generator, so it's not only the traffic you guys created. I have a traffic generator set up to automatically start sending traffic over, and you can see here, this is my app. And now I can see different cool information. Like if I hover over the shopping service, I can see the requests per seconds, the latency, the error rates. Forget about these numbers. So why my application behaves like that is because I'm really overloading it. If I click in, I can see, like, let me take a cool, like a more interesting service. Like let's go to the catalog. Where is the catalog? Let's go to the order service. So I can see the chain of dependency, exactly how traffic is coming to the service, right? And I can see information around, actually what I need to do is enable API discovery. So I'm going to do that. I'm going to enable API discovery and PII data discovery so we can see information on the data and the API calls that are happening. Now, in 2 seconds, we'll start to see which API. So until we do that, what I want to do also is I want to purchase something. So we can see that we purchased something. So I'm going to add to cart this thing. Oh, great. Hold on. I've got a cookie issue here. So this app needs a bit of fixing. This is a demo app that we use at VMware, and sometimes I have issues. How do you delete the cookies? Is it in security? No. Application, cookies. Huh? I think that should do it. Let's see now. All right, let me fix it by going to in private. That would work for sure. I'm going to buy the bike. The bike's not expensive. It's just $500. No. This is not Service Mesh that's doing this problem. It is this app. Let me log in and see if it allows me to do this. Okay, I can't purchase anything. So let's just dive. I'll fix the application later. Let's just dive here into what I wanted to show you, which is the API. So if I click on this order service here, we should start seeing, let me refresh this. You see the number of APIs here. We should start seeing these APIs now observed. So you can see exactly which API calls are happening between my services. Like this, it's been passed from the ingress gateway into the login page. We did the login, right? We posted the login. We did the order add, which didn't work, but we did apply the API call. We can actually, as a company, can go in and see a lot of good information about this API call. Like, where is it coming from? What was the response codes? How many times? What's the performance of the API? Seeing things from the API down is super helpful when we're talking about cloud-native applications that all communicate through the APIs. I can start actually troubleshooting better by seeing from application down to the infrastructure and not focusing only on infrastructure. Like if someone says the application doesn't work well and you go and see the API was slow, that can tell you that the problem maybe is in the application level rather than in the network. It's always the network though. So if I click here, I can go to the API schema, and now I can document this. I can take this and document this, saying this is how the application API schema looks. I can document that for my developers. These are capabilities that are usually reserved to the API gateways that live in the northbound of the application. Now I can work this out from within my app. But more importantly, I can then take that and apply a policy, let's say on shopping service, that says which API calls are allowed. Like you're allowed to do a get/products. Anything else is blocked. So imagine now I'm developing the application, seeing the APIs that are working, using that information to enforce how it will operate in production to make sure that only the API calls that I want are allowed to operate. It's more than a firewall. It's an API level firewall. You can think of that like that. Does that make sense? I can also do things like this service is only allowed credit card numbers. If there's like a social security numbers, deny that and give 500. Why is this important? Because what we want to protect usually is what's called PII data. And I can say that this application, these services are allowed to deliver credit cards if it will allow me to do the purchase, to drive credit cards. But if someone hijacks a different service and tries to pull credit cards, I can stop it. So I can do full leakage protection on my service mesh without decrypting the traffic, because all the traffic is encrypted. Am I making sense?
Yeah, it's pretty cool. Just another layer.
Exactly. It's another layer.
Inside.
That's, you said it right. I can also set up access policies. I can see all the dependencies. So I know shopping is supposed to only talk with, let's take an easier one. Order is only supposed to talk with payment. Okay. I want to make sure that that's what happens. I can go and set up access control policies that say, oh, I need to set up inventory first, like service groups. So I can say order and I can create also payment. First is, there you go. And now I can go and say, I want to do an access policy that says that order cannot talk with the, let's say order cannot talk with the payment, just for the fun of it. So I'm gonna do this. I'm gonna say, hold on, something is missing here. Service groups. Oh, I set it up in the wrong place. Let me set it up again. I set it up in the default instead of the order on this Acme. All right. And payment. Now it's supposed to be in the right place. So if I go to access control and I'm trying to do a new policy, now I can do that order is not supposed to talk with deny all traffic. I can do a specific port, or I can do even a specific request like deny doing payment slash whatever, right? I can actually control this on all different levels. And this is the important part. There's no IPs here. Now, anywhere there's order service and anywhere there's a payment service, they will not be able to talk. If I do, if I create this and I go here to my global namespace, you'll see the policy here, set it up here and here. I didn't say order on AWS cannot talk with payment on AWS. I did not say that. I said order cannot talk with payment. If I'm tomorrow deploying this in GKE, it will do the same policy. The policy follows the service. The policy doesn't care about infrastructure or location or Kubernetes cluster. And now I can microsegment my global namespace. It becomes an application zone. This is a top-down approach. It's very important to understand what we created here. Beyond the technology of creating a mesh, we're using this to abstract further and create zones that we can create security zones. It's called global namespaces, performance set up on this, connectivity, encryption, all of that is set up on the global namespace. Now I can do top-down where the infrastructure just accommodates what I need as an application. I think that's quite a bit for today. Any questions?
This was great, Niran. Thank you. This helped.
You like it?
The way you put together the demo. like this. This help my understanding of Kubernetes and some of the containers and the containerization rather use of. Yeah, I like this. Thank you.
Thanks, Wade. All right, Ben, thanks for having me.